Hello, in this video we're gonna see how Java handles arithmetic operations. Let's consider this first statement. Integer s is equal to 5 plus 6 times 15 minus 20 divided by 10. Java handles arithmetic operations the same way we used to do it in the math equations. There is always priorities. Parentheses are done first, then multiplications, divisions, additions, and subtractions. So here, if we want to see what happens, first I'm gonna stop all these so that we can see the result. Okay. To see the difference, I'm gonna take these off and then run it one more time. You can see here the result changed. So I repeat, Java handles arithmetic operations in the same priority that we used to do it in the math operations. Here is another example. Here I'm using the modulo. Okay. So 6 minus 5 modulo 2. First is gonna do the 5 modulo 2. Okay. Then he's gonna subtract 6 from 5 modulo 2. 5 modulo 2 is gonna give me a 1. Why? Because modulo gives me the rest, not the quotient. The quotient is from 5 divided by 2. Just a reminder for those who don't know this stuff. Of course, if there is complex equations needed to be done, Java supplies us with a class named math. It has many equations predefined. One of them here is the POW. I'm gonna give you also more examples. For instance, math dot, as you can see here, we have a lot of things that can be done. We have square root, sine, round, random. All these are available for us to be used inside our equations. So we continue. Here we're gonna show how Java handles implicit conversions of data types while doing his arithmetic operations. We have the n, which is an integer, the long ll, and the float f. If we have a statement like this, n times the long plus f, how does Java handle this? First, of course, he's gonna do the multiplication. Since he's multiplying an integer and long, first n is transformed into a long, then long times long will give us a long. Then long plus a float, Java will convert the long in the result long into a float, then he's gonna add it to the other float, and of course the result is gonna be a float. So all this is done implicitly by Java. Well, what do we mean implicitly? It means that we don't have to do it ourselves. How Java knows these things? Because of the size of the different data types that we have seen in the previous videos. Bytes can be easily transformed into short into integer, long, float, and double. Of course, as you can see here, the arrow is only one way. Similarly, the char can be changed into an integer, into a long, into a float, and into a double. Okay, similarly, it only goes one way. We're gonna see it more in action. Here, we're gonna put a double inside an integer. Java doesn't allow us to do this. Okay, later we will see that if we want to do this, we can do something called the casting. Casting is when we force a value into a smaller container, but of course we have to make sure that it fits inside of it. Let's continue. Let's see this exercise. Let's see why. Stop all these. So when I run it, you can see what's happening. Okay, let's continue with these data types and how Java handles the arithmetic operations of these data types. Here we have a byte 50, second byte 100, and a variable not initialized. We're gonna multiply them. When we multiply 2 bytes, 2 integers, 2 shorts, directly Java converts them into an integer and the result is an integer. So here it's gonna pass. While here, if I remove these like this, it's gonna tell me it won't fit inside the byte. Why? Because here Java will convert this into an integer, and this is also an integer, and the result is an integer. An integer cannot implicitly be put inside a byte. So we have to do the casting that I spoke earlier of. I have here 100,000, I have here 200,000. When I multiply them both, it's gonna bypass the maximum value of an integer. So it's gonna give us a wrong result. Let's see the result. As you can see here, first it passed here, good, it's okay. Here it's this result, and here this result, the PP, it's negative because the integer times integer is gonna give us an integer, and because it bypassed the maximum value of an integer, it gave us a negative number. Then of course this number was affected to the variable which is long. So these things happen, and we have to make sure that we are aware of their consequences. This example, we're gonna see how we can use a character inside an arithmetic operation. As I have shown you before, a character can be easily transformed into an integer. So Java knows how to handle this type of data. If I run it, you can see here if we can read, it is 10 plus 3 plus I, it gave us 20.3, which is correct. This is double, this is transformed to double, and the result is double, and it's all here. Then I is equal to a character. You can see here it is equal to a character. So here Java converts the character into an integer and puts the value inside the variable. Then here we can create also an equation, an arithmetic operation, because Java knows how to change this into the ASCII or Unicode that it refers. So here A plus 5, it gives us 102, which is the letter F. Okay, I'm gonna show you how. If we have a char C, for instance, is equal to II, it will give us non-compatible types because we cannot convert an integer into a char. A char can be converted into an integer, but an integer cannot be converted into a char. So here I'm gonna force it to become a char, and I'm gonna print it for you so that we can see the results. And here you see the 102 is the F. And last but not least, how do we convert anything into a string? Whenever we have a string, anything that comes after it becomes also a string. So I can do like this, and it will become all a string. I'm gonna stop this, I'm gonna run. We've seen this a lot when we use system without println. So it is very important to know that this and very simple to use in order to create multiple strings just using the plus sign. Thank you for watching. I hope you enjoyed this video. Don't forget to like and subscribe.